Welcome back. In this video, we are going to solve problem 5.50 that is taken from chapter number 5, Analysis and Design of Beam for Bending, and book name is Mechanics of Material by Beer and Johnston, 6th edition. So statement is for the beam and loading shown, determine the equations of shear and bending moment curves and the maximum absolute value of bending moment in the beam, knowing that K is equal to 1 and K is equal to 0.5. So you can see this is a cantilever beam having fixed support at this end, and there is a triangular load or uniformly increasing load from 0 to W naught magnitude, and in downward we have again a uniformly decreasing load having magnitude minus K naught K into W naught, and here it will be 0. The length of the beam is L. So you have to find the equation of shear and bending moment curves. So let's start with the solution. What will be the first step? The first step is that if you cut this beam at this point, let this distance is defined as x. So we will take this distance x, and this remaining distance will be equal to L minus x. So this will be L minus x. Now you can see here magnitude is W naught. So what will be the magnitude at this point? Let this will be W1, and what will be the magnitude at this point, which will be W2. So we will use similar triangle to calculate this W1 and W2. So first similar triangle is this one. You can see this is larger triangle and its side is W naught over L, and another one is smaller triangle. So this is having magnitude W1 over X. So we are interested to find out W1. So we can write it as the ratio of their sides will be equal. So I can write W naught divided by L will be equal to W1 over X. So from here we will get this W1 will be equal to W naught into X divided by L. Now for W2, you can see we have two triangle below. One is this one, clear, and second one will be this one, clear. So we will take the ratio of their side will be same. So minus K naught, I will write it over here, minus K into W naught over this entire length L will be equal to this W2, and it is acting at a length of L minus X. So L minus X. So what we will get here is that we will get W2 will be equal to minus K into W naught into L minus X divided by L. So we will have this L. And we can see that we have W1 and W2. So there is a net distributed load which will be equal to the sum of W1 plus W2. Now we will put the value of W1, which is W naught X over L, and W2 is minus K into W naught into L minus X divided by L. Okay. If we simplify it, so this W will be equal to W naught X over L minus K into W naught L plus K into W naught X divided by L, and W will be equal to W naught X over L minus K into W naught L by L plus K W naught X divided by L. If you further simplify it, so what we will get is W is equal to W naught X divided by L minus K into W naught plus K into W naught X over L. Now you can see that W naught X is common in this term and in this term. So what we will do is that we will take W naught X over L common. So we will get 1 plus K and the remaining minus K into W naught, which is the main equation for this distributed load. And as we know that dV by dx is equal to minus W. So what we will do is that we will get here dV will be equal to minus W into dx. So put the value of W in this equation, which is dV minus, and it will be W naught x by L into 1 plus K minus K into W naught into dx. So if you simplify it, so dv will be equal to minus W naught x over L into 1 plus K into dx plus K into W naught dx. So what we are going to do is that we will integrate it. So after integrating it, we will get left side will be equal to integral of minus W naught x over L into 1 plus K into dx plus integral of K into W naught dx. Okay. So from here you will get minus W naught into 1 plus K, 1 plus K divided by L and integral of x into dx plus K into W naught integral of dx. So from here we will get this shear force will be equal to minus W naught into 1 plus K into x square divided by 2 L plus there will be a sign of integration which will be C1 plus K into W naught x. We will rearrange that, so we will get this shear force will be equal to K into W naught x minus W naught into 1 plus K into x square over 2L plus C1. Now you can see C1 is a constant of integration. So using boundary condition, I will write it. Boundary conditions. We will find this C1. So what is the boundary condition? Boundary condition is that at x is equal to 0, we have shear force is equal to 0. So let me show you here. You can see here x is equal to 0. So shear force at this point will be 0. So put it in this equation. So when you put it x is equal to 0, so this term will be 0 and this term will be 0 and v is 0. So it means that C1 is equal to 0. So we will get C1 is equal to 0. Now this is the equation. When you put it in this shear force, put in above equation of V, we get shear force equation will be equal to K into W naught x minus W naught into 1 plus K into x square over 2L. And let this is equation number 1, which is the required equations of shear force for the shear force curve. Now what we are going to do is that we will do for bending moment, for bending moment curve, we find bending moment equation, which can be obtained by using equation dm over dx is equal to shear force, and from here we will get dm is equal to v into dx, and if you integrate it on both sides, so it will give us integral of v into dx. So from here we will get this moment will be equal to integral of v into dx. Now put the value of this shear force, which is K into W naught x minus W naught into 1 plus K into x square over 2L into dx. So when you integrate it, you will get moment will be equal to K W naught x square over 2, and that will be minus W naught into 1 plus K into x cube over 6L, and there will be a constant of integration C2. Now you can see that this C2 is unknown constant of integration. So using boundary condition, we will find C2, we will find C2. What is the boundary condition? So boundary condition is that at x is equal to 0, we have moment is equal to 0, because in cantilever beam you can see at the free end when x is equal to 0, so moment will be equal to 0. So you will put it in this equation. So when you put it in this equation, so this term will be 0, this term will be 0, and moment at this x is equal to 0 will be also 0. It's mean that C2 is also equal to 0. Now we have C2 is equal to 0. So put it in equation number that in above in equation of moment, bending moment. So you will get this moment will be equal to k into w naught x square over 2 minus w naught into 1 plus k into x cube over 6l. And this is the equation of bending moment for drawing the bending moment curve. Now we have solved the part first, which is determine the equation of shear force and bending moment curves. So let's move towards second part. Find the maximum absolute value of bending moment in the beam for k is equal to 1 and k is equal to 0. So for that I have to write this equation and this equation on next page. So let me write this equation. So first equation 1 was V is equal to K into W naught X minus 1 plus K into W naught X square over 2L. This was your equation number 1. And equation 2 was moment was equal to K into W naught X square over 2 minus 1 plus K into W naught X cube over 6L. So this was your second equation. Now for part 2, which is to find the maximum absolute value of bending moment for K is equal to 1. Okay, let me show you for K is equal to 1. Okay, so put the value of K is equal to 1 in equation number 1, which will give you the shear force equation. So K will be equal to 1, so it will be W naught X minus 1 plus 1 into W naught X square over 2L. So it means that shear force equation will be W naught X minus 2 W naught X square over 2L. 2 will be cancelled, so it will be W naught X square over L. And this is the required shear force equation for K is equal to 1. Now put the same K is equal to 1 in equation number 2. So what we will get is moment is equal to this K will be 1. So W naught X square over 2 minus 1 plus 1 W naught X cube over 6L, and we will get W naught X square over 2 minus 2 W naught X cube over 6L. So it will give you minus W naught X cube over 3L. And this will be the equation. Moment is W naught X square over 2 minus W naught X cube over 3L is the required equation of bending moment curve for K is equal to 1. Now we will find the maximum bending moment. So we know that maximum bending moment in cantilever beam occurs at X is equal to L, because at fixed end we will have maximum bending moment at X is equal to L in cantilever beam. So put X is equal to L in above equation of M bending moment. So what we will get is we will get this moment will be equal to m. Now m is equal to w naught L square over 2x will be replaced with the L minus w naught L cube over 3L. So it will give you w naught L square over 2 minus w naught L square over 3. So if you take LCM, so it will give 6. So 6 divided by 2 is 3. So 3 w naught L square minus w naught L square. And this moment will come out to be 2 w naught L square over 6. Okay. I think we have made mistakes. So 6 is the LCM. So 6 divided by 2 is 3. So here we have 3 W naught and 6 divided by 3 is 2. So it will be 2. So 3 minus 2 is 1. So I have to remove this 2. So this is the value of maximum bending moment for K is equal to 1. Maximum bending moment for K is equal to 1. Now what we will do is that we will move for K is equal to 1 over 2. So put in equation number 1. So which is equation number 1? This one. So I will copy it below so that it should be visible to me as well as to you people. So let's copy it and paste it over here. Okay, we will resize them. Okay, now when you put K is equal to 1 over 2, so shear force will be equal to 1 over 2 W naught into X minus 1 plus 1 over 2 into W naught X square over 2L. So from here we will get 1 over 2 W naught into X minus this will give you 3 by 2. This term 1 plus 1 over 2 is 3 by 2, which will give you minus 3 W naught X square over 6L. Okay. Let me do it for you. 1 over 2 W naught into X minus 3 over 2 W naught X square over 2L. So it will give you 3 over 4L. So shear force is, equation of shear force for K is equal to 1 over 2 or 0.5 will be this one. Now put K is equal to 1 over 2 in equation number 2, which is this one. You can see this one. So moment will be equal to 1 over 2. So it will be 1 over 2 W naught X square divided by 2 minus 1 plus 1 over 2 W naught X cube over 6L. So this will give you W naught X square over 4 minus this term will be 3 over 2. So 3 W naught X cube over 12L. And if you simplify it, it will be W naught X square over 4 minus W naught X cube over 4L. And this is the equation of moment for K is equal to equation is required. Equation of bending moment for K is equal to 1 over 2. And the last thing is that we have to find maximum bending moment. So for maximum bending moment, we know that it will be maximum where shear force is equal to 0. So make this equation V is equal to 1 over 2 W naught X minus 3 W naught X square over 4L is equal to 0, because it will give you the location where shear force is equal to 0, and then at that location the bending moment will be maximum. So what we can write is that 1 over 2 W naught X is equal to 3 W naught X square over 4L. So this 1 over 2 will cut with this, so it will be W naught X is equal to 3 W naught X square over 2L. L. And x will also cut. So I will remove this x. So here we will have this. W naught will also cancel. So we will have here 1 and this x will be equal to 2L divided by 3. Now at this x is equal to 2L over 3, we have maximum bending moment. So what we will do is that put x is equal to 2L over 3 in this equation. In M is equal to W naught x square over 4 minus W naught x cube over 4L. So what we will get is M is equal to W naught. It will be 2L by 3 whole square over 4 minus W naught 2L over 3 whole cube over 4L. And when you solve this, you will get it as W naught L square over 27, which is equal to 0.03704 W naught L square. So what we can write is that this will be give you the maximum bending moment. So we can write it maximum bending moment is equal to W naught L square over 27 for k is equal to 1 over 2, and which is the answer of our second part. So this was all about this problem 5.50. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.